Alright. Are we working? Kinda seems like it. So, yeah, we're gonna try and do what it says in the title, which is we need a way of quickly generating like 10,000 points. And I was using like pure JavaScript, and that turns out to be insanely slow. So we're going to try to accomplish this using purely the like TensorFlow API for JavaScript, because presumably that would be quicker, and I think that's going to involve broadcasting. So okay, so yeah, let me run this real fast though, because it looks cool. So yeah, so we're generating a grid of points in 5-dimensional space, and we're generating, I think, 10,000 of them, and we're doing it like in JavaScript. So like we're adding each point to this array, and it's like super slow. Okay, so yeah, like it took this much time. So I think what we need to do is we need to use broadcasting. Although I don't quite know how. So it's like the way we're generating the points is we are first generating a random vector R, and then a random vector C, and then we're doing some processing to ensure that R and C are orthogonal to one another. And then we start with an upper left vector, which will be the upper left grid point. And then for the dimensions of the grid, which I think in our case is 100. So yeah, so we're talking like 10,000 points. We literally multiply R by this offset in the grid times the spacer, and then the same thing with the column times an offset, and we add those together and then add it to the upper left and then push the resulting vector to this list. So we're trying to figure out basically how to do this loop using broadcasting. And I don't know. I'm pretty sure you can do it using broadcasting. Like, I don't know if it'll necessarily be faster. But I think the way you're gonna do it using broadcasting is you're first gonna use like this range function. So those would be like, so you would have two of these for your offsets for the rows and the columns. So if I have like a random, like say R vector, I guess just say like it's in see, I think it needs to be like in 2 dimensions though. Okay, so if I just have this random vector, so let's say it's 3, 1. Oh yeah, and also to use broadcasting. Okay, so like this is our dot shape is 3, 1. This range we also have to make it like a two-dimensional vector. So we'll say the like row offsets are tf reshape tf range 0 to 9, and I'm gonna reshape it to 1 to 9. And so just to see what that looks like. I don't know if you call array sync if that like ruins the array or something. So okay, yeah, so that's okay. So then if I take the row offsets and then I multiply by r, it should give me the r vector multiplied by 0, multiplied by 1, multiplied by 2, etc. So let's just see what that does. So we're just going to directly multiply r by my row offsets. And let's see what that looks like. So we get, is that what we wanted? No, we want it the other way around. Because we should have r 9 times. Ooh, that still didn't do it. Because r is 3-dimensional. Well, okay. I guess, I mean, you could take the transpose of this, and then I think that would be what you want. Yeah, I think this is what I want. It's just transposed. Yeah, because I wanted, because this array is 3 by 9. So actually, if, okay, so let me just go back to r tf, what was it? This one. Except I want it to be 1 by 3. And I want the row offsets to be the transpose of what they were. Why won't it let me like select that? Yeah, that. Click. Okay. So do the transpose of that. 9 by 1. And then when I do the multiplication, it should work. I guess the order doesn't matter. Okay, so we now have a 9 by 3 array. And it should be the array multiplied by 0, multiplied by 1, 2, 3. That looks correct. So this multiplication will give you, yeah. Okay, so this is going to be direction 1. So just like, I guess like x offsets. So that'll be x offsets. And then we just need y offsets. And then we somehow, again, need to use broadcasting to combine the two into an actual grid. But those are x offsets. So the y offsets are going to be basically the same thing. And we're not going to worry about the orthogonality. So we just need, I mean, it's just these 3 lines of code again. Except this is going to be C, and that is not a thing. And these are the column offsets. I mean, you can just use the row offsets, but whatever. Okay, and then okay, so then multiply C. Also, we don't want the array sync, so I'm gonna have to go fix that for the Y. But so okay, so that looks cool. And then we'll just do the same thing for the R. These are row offsets. And yeah, okay, that's fine. Okay, X. Okay. All right, so X offsets is 9×3. And Y offsets is also 9×3. Okay, so now we need a two-dimensional grid that is going to be 9×9, and each entry in the grid is going to be a three-dimensional vector. Like the ij entry is going to be the sum of the ith element in x offsets plus the jth element in y offsets. So we are adding, yeah, we're adding, and I think, I mean, I guess like you could just directly add, but that wouldn't give you what you wanted. Like if you say like add x offsets with y offsets, and you say shape, yeah, you get 9×3. But it needs to be 9×9×3. So I think you have to add a dimension. Yeah. Yeah. Okay. So we're gonna have to say, I think if you just directly do reshape the x offsets to be, because right now they're 9×3, so if you just reshape them to be 9×1×3, and then the same thing with the y offsets. 1×9×3. That should work, actually. 9×9×3. So, I think that works. So in particular, can we directly just modify our code to not use this? Because all we need to do, yeah, now we're gonna get 9×9×3. 9×9×3. Yeah, no, you can flatten that. Yeah, you'd have to like reshape it back to a two-dimensional list, but I think that's okay. So like in particular, I don't think you're going to be doing this. So you're just going to say, so I have my C, and I have my R, and I don't know what shape those are, so I'll have to figure that out. C.shape r dot shape, and oh yeah, oh okay, well they're 5, that's their shape, so we need to reshape them to be like 5 by 1, I think, and yeah, and then we also need like the grid offsets. So let grid offsets be tf reshape, tf range 0 to grid. I don't know if that's inclusive or not, but and then it needs to be reshapen because you're gonna want yeah, you're gonna want, so this is gonna be grid by 1, and C and R you're also going to want to reshape. So C is cf.reshape. To 1 by, I think just c.shape, because you're adding that dimension for broadcasting. And that should be R. Okay. So then, yeah, so then you just say like I have C offsets. TF multiplied by grid offsets. C. And same thing with R. And okay, so let's look at those shapes. Okay, yeah, so let's look at those shapes. Whoops. Where am I? Here. Binary was compiled with different shapes. Binary was compiled with different shapes than the current arguments. 115, 115 must match. Okay, do C dot shape, R dot shape, and grid offsets. What if I don't do that? I just call it up here. That'd make more sense, I think. So these need to be grid by 1. These need to be 1, 5, 1 by 5, by 5. Error and dot, inner dimensions must match. Init training at 76. maybe this needs to be like that. Okay, so we get 105, 100 by 5, and those are the grid offsets. Okay, so I think it's working. So I need to look at these. Okay, so does this look like, yeah, times 2, times 3, times 4, times 5? Yep. I'll accept that. Okay, so now we need to just take these guys and just add them together. And I already forgot how I did that. How did I do that on the other thing? Oh, just like that. Okay, cool. So I think what we want to do is just say x, which are the input points, is this. So this is C offsets, and it's not going to be it's the 9 is going to be grid, and the 3 is going to be 5 because we're in 5 dimensions. So this is grid, this is 5, that's x, and then I need to reshape it so that it's the proper number of points. So just x equals tf reshape x to be grid times grid by 5. So that should work. So let's see what that does. Y offsets is not defined. Yeah. Because it should say R. Alright. Hey, we did it. We did it. And it runs quicker. It runs more quickerly, I think. I think it runs more quickerly. Right? So, I kill that, go over here. And, okay, so let's just refresh, rerun. Oh, it's so much quicker. Amazing. That's amazing. Okay. Okay. This is very cool. This is very cool stuff, if I do say so myself. Are we still generating 10,000 points? I mean, yeah, let's... Oh, well, okay. X dot shape. Yeah, just print x dot shape. Yeah, we're generating 10,000 points. That's amazing. That is so much quicker. And so now it's trying to converge, and it failed. It's like, hello, you have to have a purple line here, dude. It's not gonna find the purple line, apparently. I think, yeah, the only other thing is, we're not, I think like we're always starting the grid at 0, 0. But I don't think that matters. It's like, it's gotta be like 100 times faster. That's amazing. Okay, so, yeah, I'm just gonna call that, I'm gonna call that a stream. So, thanks for watching.